Hi guys, I just want to go through a few of the trickier questions in calculus. We'll start off with a differentiation question. So let's just say I have a function of x which is equivalent to 1 over x to the power of 5 minus the fourth root of x cubed plus 5 times x to the power of a third. The first thing we're going to do is we're going to clean up the function a little bit. By that I mean I'm going to express 1 over x to the power of 5 as x to the power of negative 5, and we know that from our index laws. Minus, I'm going to express the fourth root of x cubed as x cubed to the power of a quarter. As we remember from our index laws, whatever that number is there, I could express it as 1 over that number over here. And we'll simplify that further in a second. Plus 5x to the power of a third. Okay, next line. X to the power of negative 5 minus, and using our index laws again, we know that we multiply the power and the power together, so 3 times a quarter is simply 3/4. Plus 5x to the power of a third. Okay. Then we'll differentiate, so I'll write f dash x, and as per normal, we're going to multiply the power by the coefficient, which is 1, so it's going to be negative 5 times 1, which is just negative 5. We're going to subtract 1 from the power, brings us to negative 6. We're going to go negative 3/4 times x, and we're going to go 3/4 take away 1, and we could do that on the side of our paper if we like, and we'll get negative 1/4. Plus 5/3, and again I got 5/3 by multiplying 5, which is the coefficient, and the power, which is a third, so 5 times a third is simply 5/3. X, then I'm going to go a third, take away 1, which brings me to negative 2/3, and we could work that out on the side of the paper if we like. Okay, now what I'm going to do, I'm just going to adjust my screen a little bit so I could fit everything there. Now, just we could see that there. Great. Okay, usually the question will ask you to express your answer in positive powers. So we can do that very simply. F dash x equals negative 5 over x to the power of 6 minus 3 divided by 4x to the power of a quarter plus 5 divided by 3 x to the power of 2/3. So as you could see here, I could express this in a positive power by bringing this to the denominator, and when I do that, that changes from a negative to a positive. Over here, same idea, I bring that to the denominator, and that becomes a positive power, and the same idea here. Now we could clean this up a little bit further as well, and that's what you would need to do to get full marks. So 5 over x to the power of 6 minus 3 over 4. Now, x to the power of a quarter is the same as the fourth root of x. Okay, plus 5 over 3x squared and the cube root there. Now let's go through that really quickly. If I just zoom my page out here for a second, if you remember our index laws, if we said we have the square root of x, that's the same as x to the power of a half. If we have the fourth root of x, that's the same as x to the power of a quarter. If I have the cube root of x squared, that's the same as x squared to the power of a third, which is the same as x to the power of 2/3. And using that principle, we can simplify our answer as I have just shown you. Okay, so what we can see here is that x to the power of a quarter is the same as the fourth root of x. What I might do just to make things clear is I'll rub out that 4. It won't let me rub out that 4, that's fine. I'll just make sure my 4 is quite big, so you could see that it's 4 times that there. I'll rewrite that in a sec just so it's very clear. Now over here we have x to the power of 2/3. That's exactly the same as x squared, and then cube root the whole thing, which brings us to the cube root of x squared. So our final answer for full marks, very clearly, f dash x equals 5 over x to the power of 6 minus 3 over 4 times the 4th root of x plus 5 over 3 and the cube root of x squared. Now I believe I've done a small mistake. I forgot the negative, which is over here. That's okay. I'll just add the negative there, and I'll add the negative there, and problem solved. So now I might add that if you were to stop at this line over here, that's completely fine because all your powers are positive. Okay, let's now do an anti-differentiation or an integration question. I'll just clear that screen there. And let's do a question that looks like this. Okay, so I might say that y dash equals 3x to the power of 4 minus 2x to the power of 3 divided by x plus 5x. Now, it's very important for me to look and say, okay, this x over here at the denominator is causing me some problems. So what I can do is I can factorize the top, and I could do that by taking x as a common factor and saying that's 3x cubed minus 2x squared divided by x plus 5x. And when I do that, it's very easy for me to cancel those two out. I'll just reduce the screen so it's easy to see and write. And then I could say that my function is now 3x cubed minus 2x squared plus 5x. Now I want to integrate that. So again, I'll move my screen. So I want to integrate 3x cubed minus 2x squared plus 5x dx. Okay, so that's going to become 3x to the power of 4 divided by 4 minus 2x to the power of 3 divided by 3 plus 5x squared divided by 2 plus c, and over here y equals. And that's our answer. Nice and simple. So the moral of the story, or the aim of this question, is to see if a student can identify that they first need to factorize to eliminate the x in the denominator there. Okay, let's do one more problem. And again, I'll clear my screen. Okay, the question might say that we have a ball and we throw that ball up vertically, and we could express the height, x, in terms of the time by this function here, 32t minus 4t squared. So x represents how high the ball is off the ground, and t represents the time taken. And the question might ask, what is the greatest or the highest height reached by the ball? And when we hear the word greatest or highest, we could replace those words with the word maximum. And when we hear the word maximum, we can be pretty sure that we're going to use calculus. So the first step would be to differentiate. X dash t equals 32 minus 8t. Now when it says the word maximum, I know that the gradient is 0, so hence I solve for t when the gradient is 0. Take the 8t to the other side. That should be a minus sign. So take the 8t to the other side. 8t equals 32, hence t equals 4 seconds. So it takes 4 seconds to reach the maximum height. But the question asks, what is the maximum height? So I substitute the 4 back into my original equation. I'll just fix the screen. So it's going to be x of 4 and that equals 32 times 4 minus 4 times 4 squared. 32 times 4 is 128, minus 4 times 4 squared, we know that 4 squared is 16, 4 times 16 is 64, so 128 minus 64 brings us to 64 meters, and that's my answer. So it takes 4 seconds to reach a maximum height of 64 meters.